How are you, my friends? In this video, I'm presenting 6 old exams questions related to basic trigonometric equations, pre-calculus course, lecture number 25. Solve the trigonometric equation 3 tan cubed of x is equal tan of x. Remember, we have to rearrange the equation, and you cannot divide here by tan of x because you lose some solutions. Let's rearrange it. Take everything to one side here. 3 tan cubed of x minus tan of x is equal to 0. Take tan of x as a common factor. So we have 3 tan squared of x minus 1. Then you can use factoring difference between two squares. So this will be square root of 3 tan of x minus 1, square root of 3 tan of x plus 1, using this nice easy formula from algebra. A squared minus b squared will be a minus b times a plus b. So now we have tan of x is equal to 0, or tan of x is equal to 1 over square root of 3, or tan of x would be minus 1 over square root of 3. Here, just to remind you that tan inverse is defined, remember, in the inverse, minus pi over 2 to pi over 2, quadrant 1 and 4. So what is the angle where tan of x is equal to 0? The angle is 0. And here we have tan of x is equal to 1 over square root of 3. The reference angle is pi over 6. And positive here, tan is positive, so this is in quadrant 1. Also, the reference here, pi over 6. But since we have a minus, so the angle itself is in quadrant 4, so it will be minus pi over 6. So the whole solution will be x equals 0 plus k pi. Remember, the period for tan is pi, and x equals pi over 6 plus k pi, and x equals minus pi over 6 plus k pi, where k is integer. Now this one is tan of x cosine of x minus tan of x minus cosine of x plus 1. Let's find all the solutions and find the sum in specific interval. So the only thing we can do here is factoring. So this equation is already arranged. You see that? Because it's equal to 0. So it's ready to be factored by grouping, because we have 1, 2, 3, 4 terms. So the first two terms, we take tan of x. In the bracket, we have cosine of x minus 1, minus, take only a minus common factor here in the last two terms. So it will be minus bracket cosine of x minus 1. So this one is a common factor. Here you see that. Cosine of x minus 1 is a common factor. And then the other bracket will be tan of x minus 1. Now, just to mention here, if you multiply these two brackets there, you will get the same equation. So that means the factoring is correct. So tan of x is equal to 1, or cosine of x is equal to 1. Now find the angle where tan is equal to 1. It will be pi over 4. Cosine of x is equal to 1. It will be quadrantal angle. X will be 0. So we can write the general solution here. So the general solution will be x equals pi over 4 plus k pi. Remember, the period for tan and cotan is pi. So we say pi over 4 plus k pi to get the general solution. Or x will be 0. See, the angle here is 0 plus 2k pi, where k is integer. Now, let's find between 0 and 2 pi. If I put k equal to 0, put here 0, so I get pi over 4. Put here 0, I get angle 0. If I say k is equal to 1, I put 1 there, so it will be pi over 4 plus pi, 5 pi over 4. If I put 1 there, it will be 2 pi. Now I need all the angles 0 closed, between 0 closed and 2 pi open. So it will be angle 0, angle pi over 4, angle 5 pi over 4. This one I don't count because this is open here. And also you can try k2. It will be greater than 2 pi. If you try k minus 1, it will be negative angles. So the solution set will be 0, pi over 4, 5 pi over 4. How many solutions? 3 solutions. If we need the number of solutions, we need the sum here. We say 0 plus pi over 4 plus 5 pi over 4, which is the same denominator here, 6 pi over 4, which is 3 pi over 2. Now this is a really nice question. We have secant squared of theta minus 1 is equal to 0. Let's find the sum here directly between 0 closed and 2 pi open. So we have to factor the equation. We can do that, factoring difference between two squares. Also, we can take 2 on the other side. We say secant squared is equal to 2. We can use the reciprocal. Remember cosine squared of theta? 1 over secant squared of theta. So instead of this equation, I can write cosine squared of theta is equal to half. Now take the square root of both sides here. You will get cosine of theta plus or minus 1 over square root of 2. And when you rationalize it, you get cosine of theta plus or minus square root of 2 over 2. So now we have cosine of theta plus square root of 2 over 2 on one side, or cosine of theta is equal minus square root of 2 over 2. Now here, let's see the plus. Which quadrants here we have the cosine, the plus? You see, look at the sign first, S-I-G-N, the plus. It will be in quadrant 1 and 4. And here the cosine is minus, so it will be in quadrant 2 and 3. So in each one, we have an angle. So let's see, in quadrant 1. Now look at the value here, the cosine of the theta, square root of 2 over 2. Look at the value. It will give you the reference angle, pi over 4. So in quadrant 1, we write this angle, pi over 4. In quadrant 4, 2 pi minus pi over 4, which is 7 pi over 4. Now here, the minus will give you quadrant 2 and 3. So we have in each quadrant an angle. And still also cosine of theta, square root of 2 over 2, the reference angle will be pi over 4. So in quadrant 2, this one here, pi minus pi over 4, which is 3 pi over 4. In quadrant 3, it will be pi plus pi over 4, which is 5 pi over 4. So we have now pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. You can put them any way you like because you are adding the 4 angles. Same denominator, it will be final answer 4 pi. Find the sum of all the solutions in degrees. So here will be in degrees. Tan of theta plus 1 is equal to square root of 3 plus square root of 3 cotan of theta between 0 closed and 360 open. Now let's start here. We have in this equation tan of theta and cotan of theta. Cotan of theta, this is the reciprocal of tan of theta. So I can replace cotan of theta, you see that one here, is equal to 1 over tan of theta. So the equation becomes tan of theta plus 1 is equal to square root of 3 plus square root of 3 over tan of theta. Let's multiply both sides by tan of theta and rearrange it. Because we'd like to make the same function here, it's easier. Okay, tan of theta multiplied by the first one, again, tan square of theta, plus tan of theta here, minus, see, bring this on the other side, minus 3 tan of theta, minus square root of 3 only, because there is over, tan of theta will be cancelled. Just make sure you understand the multiplication. Now we have 1, 2, 3, 4 terms. We can use factoring by grouping. So the first two will be take out tan of theta will be tan of theta plus 1 in the bracket. Here we take a common factor minus square root of 3. Inside the bracket becomes tan of theta plus 1. So this is a common factor now, tan of theta plus 1. The other bracket becomes tan of theta minus square root of 3. So this one is equal to 0, or this one is equal to 0. So tan of theta will be -1, or tan of theta will be square root of 3. Let's find the angles on the next slide. So tan of theta is equal -1. So tan of theta will be, the reference here is 45. See the reference 45, tan of theta is -1. So it will be 180 minus 45, which is 135. This is quadrant 2, we have tan -10. In quadrant 4, also negative, will be 360 minus 45, which will be 315 degrees. Tan of theta is equal to square root of 3, positive. See the positive here, it can be in quadrant 1, it can be also in quadrant 3. And the reference angle here is 60. So theta can be 60 in quadrant 1, but in quadrant 3, it will be 180 plus 60 is equal to 40. So when you add all these angles, 60, 135, sorry, again, 60, 135, 240, and 350. When you add them, you get 750. Just to mention here, why I did not take here minus 45 degrees if tan theta is -1. I can do that. I can say minus 45 degrees plus K times 180. Then I find the angles because there's a condition here. Guys, let me show you. Now here we have a condition. See the condition here will 0 to 360, close 0, 360 open. We have to find all the angles in this specific interval. But if we need the general solution there, be careful here. If we need the general solution for this, we can say minus 45 plus K times 180, because the period for tan is pi or 180. Be careful now. So again, because we have a specific interval, we find all the angles in that interval, and then now we add them. So the sum will be 750 degrees. Question number 5 and question number 6, similar. I will tell you how they are similar. Now let's find the solution of this. 2 cosecant of x cosine of x is equal cosecant of x. For sure here we cannot divide by cosecant of x, so we can rearrange. So bring everything on one side is equal to 0. Take cosecant of x as a common factor. Inside the bracket we have 2 cosine of x minus 1. Let's take each factor is equal to 0. Cosecant of x is equal to 0, or cosine of x is equal to half. Now remember here, cosecant of x is equal to 0, that's rejected, because the range, if you remember, the range of the graph of cosecant of x will be the absolute value of cosecant greater than or equal to 1. So it's either less than -1 or greater than 1. Another way you can see this rejected, you can take the reciprocal here. Cosecant of x is equal to 0, that means sine will be 1 over 0, which is also undefined. Now, cosecant of x is equal half, positive, so it will be in quadrant 1 or 4. The reference, pi over 3. So the angle can be pi over 3, which is quadrant 1 here, or in quadrant 4, 2 pi minus pi over 3, because this will be the reference. So it will be 5 pi over 3. So let's see, find all the solutions. See the question here? Here's the question. Find all the solutions. Just list them, put them, write them. So they are pi over 3, 5 pi over 3. There are 2 solutions there for this question number 5. Now question number 6, let's see the difference here. 2 cosecant of x cosine of x minus cosecant of x is equal to 2 cosine of x minus 1. For sure, we have to rearrange the equation. So I take all this together, you see? This is 2 terms here. So I move it on the other side. and then I can put a minus in the bracket. I can do that. Or I can put minus 2 cosine of x plus 1. You know that. Or you can take a minus, put the bracket, 2 cosine of x minus 1. In the first two terms, I take cosecant of x in the bracket will be 2 cosine of x minus 1, which is the same here. So that will be a common factor. And now we have cosecant of x minus 1 times that one. Now, cosecant of x is equal to 1 here, you see. In the other question, question number 5, it was cosecant of x equal to 0, rejected. Go back and see it. And here we have cosecant of x is equal to 1. So the x can be pi over 2. So there's one angle here. And then cosine of x is equal half, the same solutions. So now all the solutions will be between 0 and 2 pi will be pi over 2, pi over 3, 5 pi over 3. So there are 3 solutions for this and only 2 solutions for question number 5. So these are the answers of the 6 questions. For other examples, please, you can see the video on Pre-Calculus course, lecture 25, Basic Trigonometric Equations. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I wish I can see you in another video with another topic. Thank you very much.